This video is to show you how to do the procedure for the forced vital capacity and expiratory flow portion of the respiratory lab. In the previous part, we found different volumes for the lungs. We found the tidal volume, which is the normal breath in and out, about 500 milliliters. We also found the inspiratory reserve volume. That's what you're able to take in. Let's say you're about to dive underwater, or you want to hold your breath for longer. So the forced inspiratory, or the inspiratory reserve volume, is what you're able to take in. The expiratory reserve volume is just air in your lungs that you're able to blow out, but it's not being blown out during the normal tidal breath. Now, let's say I am swimming, I am doing something very energetic. I am going to take a big breath in, I'm then going to force it all out. This combination of the tidal volume, inspiratory reserve, and expiratory reserve is known as the vital capacity. So I can make a second kind of graph that measures the vital capacity over a set amount of time. So they did the procedure for the function test, and what they did in this case is they did a vital capacity test. They breathed in as much as they could, and then as quickly as possible, they forced their entire breath out. Now this is spread out over 3 seconds. That's why it looks so large. And in 3 seconds, the person exhaled 4 liters of air. Now, this graph is interesting because it tells us how quickly and how fast you are blowing out the air. At 1 second is called the forced expiratory volume at 1 second, and you should be able to blow out 75% to 80% of your forced vital capacity depending on your age. Michael Phelps probably is blowing out 90% of this. If it's under 75%, there is something wrong. And you could actually analyze the slope of this first second to find out what is wrong. At 2 seconds, you should be able to exhale 95-ish% of your forced vital capacity. And at 3 seconds, you should be able to blow out your entire forced vital capacity. Again, if you're not there, the slope is different, and you can actually analyze for where the blockage is. Because if you're not able to blow out your vital capacity in 4 seconds, you have blockage. So you're going to open BioPack, and you're going to pick Respiratory Function Test 2. So I'm going to pick Pulmonary Function Test 2, press OK. And I am John. Yes, I would like you to use it. So we're going to calibrate. The 36s are going to walk you through. The 35s, you have to follow their directions. So you're going to plug the pneumatic into channel 1. And then you're going to calibrate it. It's having you hold the handheld calibration like this. We're going to put a filter on. So when you calibrate, actually put the filter on. And then you're going to click Calibrate. And it's going to tell you, hold the airflow transducer, make sure no air is going through it. Wait for the calibration to stop. So we are done with calibration. We are going to click Continue. I'm going to go to Tasks now. It now wants me to cycle the plunger out 5 times. This is going to let it know the volume. We only have 2 of the plungers. They hold about 1 liter of air. So you guys need to basically take turns in doing this activity. So I'm going to click Calibrate. I'm going to pull it in. I'm going to pull it out. In, out. And it's calibrating. It knows that the plunger is 1 liter. So each upward spike, I'm drawing out 1 liter. And each downward spike, I'm drawing in 1 liter. So I'm going to end calibration. I'm happy with my calibration. I'm going to click Proceed. So it wants you to put the filter on. We have both kinds of filters. This filter fits a lot better. We have some of these filters. They don't fit very well. The subject is going to clamp their nose. We could just hold our noses with our fingers. We do have some of these neat, uncomfortable nose tanks, but it's important that you have your nose blocked. Then you're going to take 3 normal breaths. You're going to inhale deeply as possible, then forcefully exhale and hold it for 3 seconds. it is going to mess things up if you do not hold it for 3 seconds. So I am going to then follow the procedure. And when you're doing the recording, it's going to look like your previous data. But then when you click Done, it's going to go to the other graph view. Basically, it's taking the data and putting it in a different. So this is my forced expiratory breath right here. And see, I maintained it from 7 to 10. I maintained it for 3 seconds. If you didn't maintain it for 3 seconds, you're going to have to redo it. I'm now going to calculate my forced expiratory volume. So it wants me to take the I-beam and calculate the forced expiratory volume. You have to highlight 3 seconds. So this is my forced expiratory volume right here. So I'm going to start there. I'm going to go 1 second, 2 seconds, 3 seconds. So it says 3 seconds right there. I'm then going to click Calculate Forced Expiratory Volume. So it calculated it, and my forced expiratory volume was very low. It's 1.5. I apparently did not calibrate it right. I know mine is about 4.5 liters. And now you are going to do another set of calculations. So when you click Done, you should get the screen. Show grid. It'll make it a lot easier. And I want to get rid of this journal, so I'm going to just go here, pull it down, and that's going to give me at least half units. Now, to find out what this value is, I just moved the cursor over here. I highlighted it, and I'll highlight this whole thing. I breathed out 1.81, 1.82 liters in 3 seconds. So again, my calibration was off. Now, I'm interested in the forced expiratory volume at 1 second. That is this one. Forced expiratory volume at 1 second. So I'm then going to highlight that number. My forced expiratory volume at 1 second is 0.99, or sorry, it's 1.5. So I write 1.5 in right here. So here I'm going to write 1.5. Then I'm going to do the same thing at 2 seconds. So I'm going to highlight it from 0 to 2 seconds, and that number is 1.7. Then at 3 seconds, it is 1.8. So I'm going to write those numbers in. Then my forced vital capacity, that's how much I was able to blow out. Well, that is 1.8 right there. So I write that there. Then to find the forced expiratory volume, that is how much we blew out at each second. Forced vital capacity ratio. We basically divide this column by this column. So this is 1.5 divided by, I believe I said, 1.8. And I get 1.5 divided by 1.8. Yay, I'm normal. It's 83%. So, again, normal range 70 to 83%. Repeat it for 2 seconds. Repeat it for 3 seconds. And then you find the percent. So, my calculator is actually 0.83. Well, that's the ratio. Then I multiply by 100 to get 83%. And that is how you do part 2.